Welcome to the video on text analytics. So what is text analytics? Let's look at it. So it deals with unstructured data in the form of text, written content, etc. So it uses data such as emails, web content, news articles, application forms, transcripts of audio recording and stuff. Then it converts unstructured data into a structured format such as matrix, and it uses different analytical tools, descriptive methods to analyze data. It uses machine learning, data science to build predictive models, and then we use those models to basically predict, the values, unknown values. So here is the graph which shows that how the percentage of it's a comparison between structured data and unstructured data available in the world. You can see that unstructured data is huge compared to structured data. That's why it becomes important to look at unstructured data as well for data science and model building and stuff. So the need and challenges when it comes to text analytics. So why do we need to do text analytics? Why we need to work on model building based on text data, unstructured data? So as we all know that after information technology revolution, the amount of data being generated online, especially now even on smartphones, computers, internet, being uploaded on internet. We have example of YouTube, social media sites, and blogs and websites, and there are so many other platforms. So there is a sudden surge in data generation after information technology revolution, whether we have been experiencing for decades now. So there is a huge amount of data being created, generated every second in the world actually, and by different people all over the world from different countries, different languages, not just English but many languages. And a lot of this data is unstructured data. As we saw the graph that structured data is very tiny compared to unstructured data, and some of this data may be garbage. In fact, a lot of it could be garbage, but there's still a possibility of some portion of this unstructured data being very useful. They may have some stories to tell. So these useful structured data can change the course of how businesses operate, and there are many such examples. That how this, for example, a recommender system that's built on of course it uses structured data also, but it mainly relies on unstructured data, where based on comments and based on like social Facebook, for example, YouTube, for example, they all depend on a lot on unstructured data, comments, posts, those things. So social media, for example, is full of unstructured data, and it is being monetized by all, like YouTube, like even Facebook, and so many other places where people are using these social media sites to monetize, to earn money. Businesses are using these social media sites to increase their profitability, to use it as a marketing tool. But again, with this comes a lot of challenges. So the main challenges are that these data, these unstructured data, they are very highly unstructured, and they are not readily available for statistical analysis, which means that a huge amount of pre-processing is required. So, and there is a huge quantity of documents containing unstructured data. It's called big data. So, how to deal with that? That's the challenge. So, what is the difference between text mining and data mining? That's what we're going to see. So, the text mining works with the documents, while data mining works with data set. So we readily get data set and we start working on it. Here we get documents like in the form of text. When we talk about documents in text analytics, does not mean only files containing pages after pages, or many files like that. In text analytics, documents could also mean as simple as a comment in a post, like Twitter. Let's say some celebrity post something on Twitter, and then there is a million of comments on that particular post. So each comment can be considered as a document. That is also a kind of document in text analytics in data science. Now the next step is prepare and process data. That's what we do even in data mining. But the main difference is here. Here we straight away select the features. Features means independent variables, right? Explanatory variables. So we since we already have structured data and we just straight away pick up those features. Here we have to extract features from the text and then select those features using algorithm. It's not like we can do it manually. So we run algorithm to select those features. So this is the main difference here. And then again, analyze distribution, both same. So feature extraction. So what do we do? Analyze the phrase, the steps that we follow. Analyze phrase counts in a text. So this is what, that's a first step. Like, then we create bag of words actually representing frequencies of words or combination of words. What it means is we create bag of words means different words. Like, it's like, let's say different a vector containing so many words, right? Or matrix containing words or table containing words as the features, and how many times each word has been repeated in different documents. So that is what it gives. Or combination, we can also use phrases instead of just using a word. So we need to perform a great amount of pre-processing before getting frequencies of words. So that we will see later how it works. This is a simple example I've created here. So document number means in the first document, the sure word doesn't exist. This is 0 and 1. It's only in 0 and 1 format. 0 means the word doesn't exist in the document. 1 means it exists. That's all it is. So so the word like exists, interest exists, learn, everything, and then need. All these words exist in document 1. Well, 0 like sure, life, create, amount, they don't exist in document 1. So likewise for all the other documents. So pre-processing steps. So let's look at that. So first step is we stem the words, right? What we do is, of course, first we separate all the words. Like if they're, if we are picking up a string, like, one sentence, it could be in a string. So so we can use, different codes to first separate those words. So there are tools, there are packages and functions to do that, to read those sentences and then how to break them into different words or phrases. So after we've done that, then what we do is we stem the word. Like what is the meaning of stem? So we go back to the root word. So for example, helping, helped, helps. The root word is help. So we turn all these words into help. Same with go, went, gone. So it will become go. So Potter stemming. So this is an algorithm which is one of the industry standards for English language. So a lot of people use this Potter stemming for this purpose. Then remove all the stops words. What are the stops words? Like all the articles like a and the, then auxiliary verbs like is, are, am, will, can, could, then as, if, but, what, who, when, they, I, or, neither, either, and there are many other stop words. So we remove all these stop words because they don't add any value to our analysis or modeling. So we get rid of these stop words. Then we remove extreme rare words appearing in the documents. Like if a word is appearing less than 0.5% time, it doesn't make sense to use that. Sometimes it may have the story to tell, but that depends on domain. But usually we get rid of extremely rare words, in the document. So calculating frequency, how do we calculate? There are various ways, but the most famous one is known as term frequency versus inverse document frequency. Term frequency, inverse document frequency score. It's the most popular one. How to do it? So this is the formula. Term frequency IDF inverse document frequency is calculated like this. First term is your term frequency, and second is uh, inverse document frequency. So N stands for number of documents in a corpus. Corpus means the collection of documents that you have received, for your analysis and for model building. So the corpus will have many documents. So number of documents in the corpus. Fij is frequency of word in document I. So in a document I, a particular word, the number of times a particular word has appeared, that is the frequency of that word in that document. That's why it's called term frequency. Word is used as term, so how many times that term has appeared in a document. Dj is the number of documents containing that particular word. So out of all the documents, how many documents have got have this word has appeared in, So for example, let's say word like has been repeated 300 times in a document containing 10,000 words, right? So there are, let's say, so many documents. Out of all the documents, one document has 10,000 words. Out of this 10,000 words, the word like has been repeated 300 times. So the term frequency for like in this document will be 0.03, right? And then let's say the same word has appeared in 10 different documents out of 1,000 documents. So this is the corpus of documents we have. So inverse document frequency will be log of, so n is the number of documents, which is 1,000. dj is the number of times that particular word has appeared, or dj is the number of documents in which this word has appeared. So that is 10. So log of 1,000 by 10 is 2. So tf-idf becomes 0.03 into 2, so 0.06 for that particular word like for that particular document. So TF will keep increasing if the word is repeated multiple times, So there are words who have the tendency of repeating themselves again and again in all the documents. So to offset that value, let's say some word like, uh, although we get rid of words like the, but let's just to understand the example now, a, the is they appear so many times in all the documents, right? So giving higher weightage to them doesn't make sense. It's better to give higher weightage to the words which tell us some story, which are important. So that's why we use IDF. This term was introduced to offset that effect, So how does it work? Let's say the word the, has appeared many times in every document. So TF will increase, the term frequency will increase because of that. But what about IDF? So IDF is the inverse document frequency, right? So log of n by dj. Now that word d has appeared in all the documents, so it will be 1,000 by 1,000. So the log of 1 will be very less, right? As opposed to a word which does not appear all the time, it appears only in 10 documents. For example, this word like. So then the value is 2. So this IDF has given more weightage to the word like, which appears less number of times, than the word the, which appears more number of times in more documents. And therefore it gives more weightage to the word which repeat less number of times compared to the words which repeat more number of times. That's what the purpose is. Clustering. So basically what we are trying to say is we can use clustering to group the documents in different clusters dynamically. That means as and when they come in, because it's like a text analytics, like documents could be your web page also, right? Email also, right? So as you get the email, I'm sure you would have seen how Gmail, segregates these emails. It puts into spam, it puts into promotion, so these are different folders created by, so it automatically transfer them to this, but that could be the example of classification also. All I'm saying is that this is one example how we can use text analytics to put documents into different clusters. So we use feature vectors for both for the clustering, and then this is how it works. So the document is received, the clustering tool or algorithm, what it will do is dynamically it will keep segregating those documents into clusters, 1, 2, 3, or many clusters, depending on the features, how we have trained the model, it's unsupervised learning, right? Same way we can use classification to classify documents into different categories for intended use. So as I said, I give this example in the previous clustering, but basically that fits in here actually. Spam, promotion, work, home, so you classify those documents or emails into different folders. So categories defined by sample documents. So basically, to train a classification model, you need training data, right? So this can be provided by the domain experts who have already tagged those documents into different categories. So we need the training data because we need response variable, right, for classification. It's a supervised learning. Clustering is unsupervised learning. So then we based on this we train the model. So and user provide taxonomy based predefined categories, something like that. So there are two steps. So first step is train the model using training set, that is sample documents. And then what you do is you classify, categorize new documents as and when they come. So this is the first step, sample document, then train the model, and then we create a classification schema. And then we feed this schema here to create this classifier categorizer. So as the new documents come, this categorizer or classifier will automatically classify them into different categories. So text mining in R, what I have done is I've provided the codes here, R codes here for you to understand. So for pre-processing, basically once you pre-process the uh, text data or unstructured data into structured data, then you can use any method, like you can use unsupervised learning for clustering if there is no response variable. If there is response variable, then you can use classification for that. I mean, that's what it is used for, right? So there is a package called TM in R, which we use for pre-processing the data. So let's say I'm just giving sample code here. So I'm reading the document .csv, which has all the text, right? And then what we do is after reading, we just take the column which has got only text and ignore all the other columns. So each row will have one column, one document or one text, something like that. So this corpus function, what it does is part of TM. So this transforms it into a collection of documents. So right now it's just a data, simple, like column or row data. So we need to convert it into a collection of documents so that we can process it further. Then you can inspect, like it will have many dimensions, like if there are 300 rows, then there'll be 300 lines or documents, as per this. So this is to inspect the first row, actually first document. So it will show some result which you can analyze. And then what we do, we use a function called tm underscore map. The job of the tm underscore map is to do all those stemming that we saw, right? Stemming, then to lower means it will put all the transform all the words into lower cases. This is one step important. We always transform all the words into lower cases to get the uniformity, So and then what we do is, and the reason is also, like there are, like you may have a documents in one document the word would be in uppercase, another document could be in lowercase. So it's better to put all the words into lowercase. Then again, we are using the same function again here. Then this is to remove punctuations. We don't need punctuation, right? So we are going to analyze our data based on the words, actually. So we don't need punctuation here. They don't add any value. Then remove numbers. We get rid of numbers also. Basically 1, 2, 3, 4. All those numbers are not useful, actually. As you practice and go deeper into text analytics, you will understand why we remove numbers also. But they don't really add any value. Then my stem document, so it will stem the words, right? Like we saw, like those helping, so it becomes help. So that's what we do here. Then we remove words like stop words. So this is like if you want to remove, so you can use this inside one argument in this remove words, and you can give your own a list of words also to remove, like some vulgar words also. You can use the same argument to do that. Here we are using stop words, so we are removing all the stop words. Remember we saw like all the auxiliary verbs like is, am, are, we, and then the articles a and the, and the other words like question words like what, where, and all those, and all the pronouns I, they, he, all those words, they don't add value, actually. That's why we get rid of them. Then if there are white spaces between words, so we remove them also. They are not needed. And then transform it into a plain text. And then as I said, this applies transform. TM underscore map function applies transformation to corpora. If you type this get transformation bracket, it will give you the list of all the components, all the arguments, or all these actually functions, inside this, all this. So, and but mostly we use this only, like plain text document, remove numbers, remove punctuation, stem document, strip white space. So mostly we use these 1, 2, 3, 4, 5, these 5 ones. Then convert back to data frame. Just to show you, if you want to convert, you convert into data frame. But we usually, what we do, we convert it into document term matrix. So this is where you can use, weight. So we saw like term frequency, inverse document frequency, right? We also have an option of weight TF, only term frequency. Depending on what you want to use, how you want to use, depending on your domain and all, you can choose between these two. So we provide these arguments within this function document term matrix. Okay, and then you provide whether you want weight TF or you want weight tf-idf, and minimum word length should be 4 or whatever, like that depends on you, like, again. And you can check the dimension of this. And removing sparse words, so what does this do actually? So see, there are words. So this is what you see here is document frequency of word J. The document frequency means how many times that word, how many documents in total number of documents contain this particular word, right? So in how many documents this word has appeared among all the documents that we have, the corpus. So what it does is, this is the formula. If this document frequency is greater than this value, which is n is the total number of documents multiplied by 1 minus 0.098. So this is the sparsity we are looking at. You can make it 0.98 also, 0.9, sorry, 0.99, 0.95, whatever you like, depending on again your domain, like based on what domain you're working on. So what this will do is it will 1 minus 0.098 will give you 0.02. Let's say their total number of there are 100 documents, so it will make it 2, right? The total value will become 2, right? 0.02 will become 2. So if the document frequency is more than 2, that means if the word has appeared in more than 2 documents, right? Because there are total only 100 documents. So if the word has appeared in more than 2 documents, then we will keep it, we'll retain it. Otherwise, if the word has appeared only in 2 or less than 2 documents, then we get rid of it. Then we don't retain that word in our data. So this is the function remove sparse term by, so this is the, right, this is the variable, right? And then we put this, and then we finally convert that into a matrix. Once you have this data in a matrix form, which will be like, you'll have a columns, and the names will be the words basically, the column names will be words. So each column is one feature, and that feature is the word actually. And it will give you, depending on what you have used here, it will give those values. And then once you have that in matrix form, then you can apply whatever you want. If you have a response variable also, then you can build classifier. If you don't have response variable, then you can build a cluster, or you can also generally analyze that and do whatever you like, predictive models, whatever you like, you can do that. So thank you so much again for your precious time and and going through this presentation. I hope it has given you some insight into text analytics. Of course, this is just a basic. You need to do a lot of research, go online, do some practice, write those codes and get some data, raw data, and work on that. Build models so you'll get confidence and you'll enjoy the process. So thank you so much. If you like the video, like, share, and subscribe.